Okay, students, here's another typical problem that we deal with ellipses. This one says the opening under a bridge is in the shape of a semi-elliptical arch, has a span of 96 feet. The height of the arch at a distance 15 feet from the center is 22 feet. Find the heart of the arch at its center. So this drawing pretty much completely gives everything you need, with one exception. What we want to do is we want to find this height right here. That's what we want to find. And we're dealing with an ellipse because it says it is a semi-elliptical arch. Always make sure you read the problem and find out what type of figure you're working with. So in general then, we're working with x minus h squared over a squared plus y minus k squared over b squared is equal to 1. That's just our general starting point here. And one of the things that we learn is that the hk coordinates, unless you're specifically told in the problem differently, you can always set them at the origin. That's always the way to go with that. So really, I'll change colors here. If we shorten this, we're really at x squared over a squared plus y squared over b squared is equal to 1. And always try to do that. Always try to set your hk at the origin every time you can. Okay, so we've got that part. Now all we have to do, we want to find this height right here. And that height is really the length of the minor axis. Because if you look at this, this is a half ellipse, but if we were to just keep drawing it, it would make a regular ellipse. Our major axis would be this blue segment right here. So B would be half of that, which turns out to be just this H segment. So when it's all said and done, we want to find B in a problem like this. That's what we want to find. We want to find B. So in order to find B, if we put in a number for X, Y, and A, then we've pretty much got everything we need. All right, so let's do that then. A is the distance from the center to one of the major vertices. A in this case is going to be half of 96. If you take 96 and if you divide it in half, you should get 48. So I have x squared over 48 squared plus y squared over b squared is equal to 1. Now all I have to do is plug in a number for x and for y. Well, any point on the ellipse is going to work. I do have a point. I have the point 15, 22. So I can now substitute 15 squared over 48 squared plus 22 squared over b squared is equal to 1. Now all I have to do is solve for b. Well, it's just a matter of algebra. I'm going to pause the video and pull up my calculator, and we'll look at that in a second. Okay, we're back. Of course, that was a quick pause. I stopped so I could pull up my calculator app on my smartboard here. So what I want to do is, algebraically, this 15 squared over 48 squared, well, that is a number. And what I'm going to do is I'm going to subtract it from 1, whatever that turns out to be. And then I'm going to have 22 squared over b squared is equal to that number. And then I'm going to do the math from there. So let's start off by first finding out what 15 squared over 48 squared is. So if I go to this, I'm going to clear everything out. Not sure what else there, but 15 squared divided by 48 squared gives me that number there, 0.097656525. I'm going to subtract that from 1. So 1 minus, when I hit second negative, that pulls that answer in. I get 0.90234. 0.90234. So that goes right here. 0.90234. Let me pull this back up just to check. 0.90234. And I can do this all on the calculator, but I'm purposely showing the algebra right here on this one. Okay? So this is a proportion. To do any proportion, you cross, multiply, and divide. So 22 squared over 0.90234 is equal to b squared. So I'll take that squared away. So b is going to be the square root of all that. So what I want to do is take 22 squared. I want to take 22 squared, and I want to divide it by that 0.90234, and then I want to take the square root of that answer, and I get 23.1599. So we'll call that 23.2. Go ahead and just call that 23.2. So B is 23.2. So hopefully that makes sense. If we go back up here, so we're saying that the height here is 23.2 at the center, and that should make some sense because it should be more than 22. Now, are we going to know exactly what it is? Well, maybe not, but 23.2 is probably a good estimate there. So 23.2 feet. Okay, a next problem that we look at looks like this one. I've already done a few drawings here, and this one will go a lot quicker than the other one. It says a skating park has a track shaped like an ellipse. If the ellipse of the track is 74 meters and the width of the track is at 38 meters, find the equation of the ellipse. Okay, well, in general, the ellipse is going to be x minus 8 squared over a squared plus y minus k squared over b squared is equal to 1. And the trick with this one is nowhere does it tell you where to place the center, so we're going to make it 0, 0. So we're just simply going to start with x squared over a squared plus y squared over b squared is equal to 1. Now, it also does not tell you the orientation of the track. In other words, we don't know if the track is vertical in orientation or horizontal. We don't know, and as it turns out, it's really not going to matter. Oh, my goodness. Hang on a second. Pause here. I don't know what happened. I'm going to have to get out of this except to orient it. So y'all can laugh at me in this video because I'm not going to erase it out. Okay, going back to the picture. It's either horizontal or it's vertical. We don't know, and it's not really going to matter. Okay, another problem with this. People think that it says that the length of the track is 74 meters, meaning that the distance around is 74 meters. That is not what that is saying. It is saying that the length from end to end is 74 meters. All right, so why do we put the origin as the center point? Because if we just drag this through here, like this and this, we have a horizontal and a vertical major axis and a horizontal minor axis. So that means this then, we're dealing with x squared over, and if our minor axis is 38, half of 38 is 19, plus y squared, our major axis is vertical, half of 74, I'll pull the calculator out, some people like to see this, 74 divided by 2, well that's 37, so I know then, okay, now 19 squared and 37 squared, 19 squared, 37 squared, actually you really should write these out. So we have 361 and 1369. So that should be 361, that should be 1369. So that's y squared and x squared is equal to 1. Okay, now this is a perfectly acceptable answer. But what if you said, no, Dr. Potter, our major axis is horizontal and our minor axis is vertical? What the heck is that going to do to the equation? Not a thing, except it's just going to switch the x and the y, because now you're going to have x squared over half of 74, 37 squared, plus y squared over half of 38, 19 squared. That is equal to 1. And so 37 squared is 1369. 19 squared is 361. We set that equal to 1. So you notice that the only difference in these two is the position of the A and the B, but they're both the same. So I would take either answer for this one, unless you're specifically told in the problem. If you're specifically told in the problem about the horizontal or the vertical major axis, then you should pay attention to that. So that's that type of problem. That one's pretty straightforward. The last type of problem we're going to look at looks like this right here. Find the standard form of the equation of the ellipse given this stuff. All right? So, first thing, we're going to have x minus h squared plus y minus k squared over a squared and b squared. Right now I don't know where a squared is going to be or b squared. It's going to help me to plot some points. So what do I know here? Well, I know my foci are at plus or minus 2, 3. So if I go plus 2, 3, if I go minus 2, 3, I know I have foci there. Which means then that my axis of symmetry, my major axis, must be horizontal. And that tells me then that my A has to be under the X. So very quickly we spotted, because the foci lie on the major axis, that we have a horizontal major axis of symmetry. Okay, so that identifies A and B. Now, let's put some numbers in for this thing. So I have x minus h, y minus k, a squared and b squared. H and k, that's my center. It should make sense to you that the center is the point that is midway between the two foci. So if I look at the distance between the two foci, it's a distance of 4. That is a distance of 4 right there. Half of 4 is 2. So if I take 2 away and add 2, now however you want to do that, it should be obvious that the center is the point 0, 3. Which means then that my ellipse should start to look like this. X minus 0 squared over a squared plus y minus 3 squared over b squared is equal to 1. Now I got to figure out the other part. Well, I have another clue. The minor axis has a length of 4. That refers to my b coefficient. B is not the length of the minor axis. B is half of the minor axis. So if my minor axis has a length of 4, half of 4 is 2, so that's a 2 squared up under there. Now all I need to do is find A. Well, remember in the ellipse, excuse me, the relationship between A, B, and C is this. C squared is equal to A squared minus B squared. So algebraically, C squared plus B squared, the square root of that, is going to give me A. Well, we know what B squared is. B squared is 4. So B squared is 4. How are we going to find C? Well, remember, C is the distance of the foci from the center to each foci. We know, excuse me, that distance is 2, so 2 squared is 4. So A is the square root of 8. Now that can be broken down into 2 square root of 2, I know that. But for our purposes here, I'm just simply going to erase this right here and put the square root of 8. Now all we need to do is simplify this, because we should always simplify our numbers. So x minus 0 just becomes x. Square root of 8 squared is just 8. Y minus 3 stays as y minus 3, and 2 squared is 4, is equal to 1. So that is the standard form of our equation.